All right, y'all, welcome aboard. Let me share a screen with the warm-up for y'all. Oh, wrong one. Just do this. And as you can see, we're just a day off where we normally would be. Okay, so here's the warm-up, and we're going to do the same thing. I'm going to wait till 1:05 before I unmute everybody, and then we'll move on. Hey, welcome aboard, y'all. This is the warm-up, and then I'll wait till 1:05, give people a chance to get here. All right, y'all coming one after the other. Boom, boom, boom. Hey, how's everybody doing? So this is the warm-up, and we'll get started at 1:05. Okay, we got 12 of y'all right now, so we got a whole dozen. So this is the warm-up. All right, we got about 2 more minutes, maybe 1. All right, y'all, welcome aboard. Got about 15 of y'all right now. So again, I'm gonna wait about a minute or 2, and then I'll unmute y'all and we'll move on. So. All right, I'm gonna go ahead and unmute everybody. All right, how's everybody doing today?
Great.
It's kind of foggy over here. It's misty this morning. Y'all want me to go over the warm up, or you want me to wait a minute? All right, I'll wait a minute nonetheless, give other people another chance to get here. So today we're going to start looking at simple and compound interest, or at least that's what I plan. And let's just see how this goes. It's hard to kind of decide what's efficient medium. So we'll just see. Okay, I'm gonna go ahead and go over this. So what's going on here, as I stop the share, is we have credit card charges 16% interest per month on any leftover charges. And this is typical how high the interest is on credit cards. Sometimes they get as high as 24%. And that's per month. So if you have $800 left over, how much is the credit card going to charge you? In addition to, they might even charge you a fee. It's good business when you're in banking. So you got 16%. So one way of doing this is increasing by 16%. That. All right. But there's an easier way to do this. And here's how you can think about that. If I put 1 times 800, right, that's still 800. And notice we got a common factor of 800. So here we got a 1, and there we got a 0.16. So if we factor out the 800, we get 1 plus 0.16. This is called a growth factor. And it's very helpful because if you want to increase anything by 16%, just multiply 1.16. So if we didn't pay this bill for 2 months, then we would just put an exponent of 2 there, because we would have had an increase of 16% twice over 2 months. So this growth factor would be multiplied twice. So you can see this is very helpful, right? And anyway, that's how you get the answer in the warm-up. Okay, now the second problem was that one. So your expenses decreased. This is so awkward. I got to go left instead of right. Your expenses decreased by 15%. Last year, the expenses were $20,000. So how much are they this year? Well, this is kind of a similar problem, except instead of plus, we're going to subtract. All right, so we got 20,000 minus 15% of 20,000. And so that's how we can decrease by a percent. That means a percentage of the original is what we're going to subtract. Whereas here, it's a percentage of the original that we're going to add. Okay, so we can do it that way, but we could also do the same thing we did up here. Up here, it was 1 plus because that was a plus. Down here, it's going to be 1 minus. Okay, and so you get that. Now, this is called a decay factor, but in economics, it's called a depreciation factor. Right? In sciences, when you talk about like an isotope decaying, the nucleus is being radioactive because it's got an unbalanced relationship between the neutrons and the protons. That's when we use the word decay. But in economics, we'll use the word depreciation factor. But whatever it is, it's a number that you're going to multiply to create a percentage of decrease. And when we do this, this winds up being 0.85 times 20,000. Which means another way you could look at this, if we take away 15%, we're going to have 85% left. So we got 85% left of the original. So you could think of it that way too. Okay. Landon, good to see you, buddy.
Yeah, what's up? Sorry I didn't make the last one.
Oh, good. I video recorded it, so you can.
Okay.
Yeah.
Yeah, it's on Classroom, right?
Yeah.
All right, sweet.
So now we got the third problem, and that third problem is this one. So the investment fund, this is so awkward. I'll probably get pro in a month. The investment fund grows about 1% per month. How much will 5,000 be after 3 months? Okay, so this is where you got your money in some kind of fund. Now, does that mean stocks? Does that mean bonds? Well, it depends. You probably have somebody doing this for you, so they're probably going to mix this up. Now, of course, you might have more than this, but it's just a problem. So this is increasing by 1% a month. This is where this is going to become handy, because if we have to do this 3 times, we'd have to multiply this by 0.01. That would equal 50. And then we add the 50. So now before the second month, we'd have 50/50. And then we got to multiply by 0.01. And then this would be 50.5. Right? So now after the second month, we would add 50.5. So now this is 5,100.5. And then we got to multiply the 0.01. So notice how much longer this is taking. And then this would become roughly 51, technically 0.005. And then we add that to this. And so after all that work, finally we get to the answer. So after 3 months, if it grows 1% from the previous month's value, this is what we'll have. So we'll make $151.50 in 3 months from this 1% investment. So you can do it that way. You know, multiply, add to the original, multiply, add to the original, multiply, add to the original. But this would be a lot easier if we created a growth factor by adding 1 to 0.01 and raise this to the third power. That would be a whole lot easier, because then we could get that answer immediately. Okay, and this is kind of the stuff we're going to look at today. At least that's my hope. So we'll see how that goes. Let me admit somebody. Connor just showed up. Okay, anybody want to ask anything about that or text me anything about that? Good? Oh, I just touched my face. Oh no! It's okay, I wash my hands like all the time now. Geez, I've never done more hand washing in my life. Okay, so let's go ahead and look at the homework. Now, I went ahead and, again, as I usually do, shared the solutions with you all. I only did the evens. And for the word problems, I just set them up. This last word problem to me was probably one of the harder problems, right? But is there any particular one you want me to go over? Because I might jump around a little bit. So you can just text me or say it out loud. I mean, y'all may feel comfortable because you have it as, you know, examples. I don't know, but. All right, I'll wait a couple seconds and I'll just start pointing out a few things. Okay, number 4, okay, definitely was going to go over number 4. Thank you. 28 and 30, 26 and 30, okay, so 4, 26 and 30. And number 7, okay, number 7. All right, number 7 was an odd problem. So I'll try to get to it. If not, I'll go ahead and do it and post it. So, okay, I got to dig that up. I didn't do that one. I only did the evens, but I'll take care of it. Don't worry about it, Kenneth. All right, so number 4. Now, number 4, notice that with number 4, you got this ellipse. Now, that's an ellipse because 9 and 4 are not the same number. So it's going to be an oval kind of shape. Okay, and then this is a line. Now, there's 2 ways you could do this. You could either take this second equation, solve it for y, or solve it for x, which is what I did, and then go ahead and replace it in the x squared with the 9x squared. So that's what I'm doing over here. Thing with that is you got this fraction, right? And so there's probably an easier way to do this problem, but just to point out how you could handle this if this is what happened, right? So since it's a fraction, I wanted to take out the 1/3. And so I factored out the 1/3, which means this would have to be 6 so that it becomes 2, 6 1/3, and then this is 2. And now when you apply your exponent, this becomes 1/9, and then you don't have to really deal with that fraction as much, and then you can just multiply everything by 9, right? That's one way you can handle that. Another way that you can handle that, notice that if we solve for 3x and we squared 3x, we would get 9x squared. So we could solve this for 3x. So 3x is 6 minus 2y, and then square that. And so we got a way to replace 9x squared. And notice we're really getting to the same end. So that's another, sometimes you can do that if these two coefficients are related by a square. So in this one, you could do that. But a lot of times you can't do that, so you're going to have this fraction kind of stuff. Okay, so then once you get there, it's just a matter of multiplying this binomial, and so that's what this is. And then now when you combine your like terms, and then since you got a 36 on the left and a 36 on the right, you get 0. And then you factor out your 8y. And so that's why this is y minus 3. And so now you got your zero product properties. So either 8y is 0 or y minus 3 is 0. So here's your two solutions. And I scratched something out. I can't remember why. I did this yesterday. All right, so now all you got to do is replace that into the equation up here that says x. So 0y and 3y. And so that's where you get this. Okay, Juliana, I got that. I don't know about the odds. I'll try to do the evens today, but I'll, if worse comes to worse, I'll just do these and then send them to you. Okay, so I wrote them down. All right, so let's see, y'all wanted to do 26 real quick. Okay, so 26, you got this situation where you got 2 bits of information that's given to you. And one is that the perimeter is 6, and the other is that the diagonal, which would be that, is √5. Okay, well, since we know the perimeter is related to the surrounding sides, and we can use the Pythagorean theorem with the diagonal, then if you label x, y as your sides, then 2x plus 2y is 6. Give me a second, I'll answer your question, Connor. Then you would get your Pythagorean theorem for x squared plus y squared equals the square root of 5 squared, so that's why that's 5. Okay, and then it's just a matter of solving this. What I would do is I would divide this by 2, so you get x plus y equals 3, and then just replace x or y. That's what I would do. Okay, and then now 30 was a doozy. 30 I might do on the board a little bit. So you can see with 30, it's kind of the same thing, but the way they give you the information is a little differently. All right, so basically they tell you that the diagonal is 1 foot longer than the length. Okay, so then you can go ahead and represent the diagonal equals L plus 1 and then solve for the length. So that's why I put D minus 1 there. Okay. Now, they didn't give us a way to relate the width, so I just labeled that X. And then the diagonal being the diagonal, I just put that as there. So D. And then they told us that the diagonal was 3 times longer than twice the width. So that's the second equation. Okay, so basically what we're going to do is have a Pythagorean theorem where we're going to be d squared equals x squared plus d minus 1 squared, and then use this second equation to substitute 3 plus 2x for d. right? And that's basically how you get to the end resulting equation that you're going to solve for x, right? And so that's how I got to here. And then it's just a matter of multiplying the binomials. You're going to get a quadratic. It's probably factorable. A lot of these were factorable. Okay, and then let's see, 22. Let me go to 22 real quick. Okay, yeah, 22 was a doozy. So here, again, this first equation, notice that you got the 4x squared and the 9y squared. So 4 and 9 are not the same, so this is an ellipse, it's an oval. And then you got this linear equation, so I solved it for y. And then I just replaced the y here with the y squared and the 9. I just replaced that with 8 plus x. And so then multiplying that out, notice I'm not multiplying the 9 first. I'm doing the binomial 8 plus x squared first. And then I did the distributive property with the 9. And then I collected the like terms, got it equal to 0. And then I tried to manipulate the factors of 13 times 560, and then it wasn't factorable, but I gave it a shot. But that's how I was thinking. That's what this is. So, okay, can't factor it. Maybe it's factorable. It's too hard. Quadratic formula. Okay, so A is 13, B is 144, C is 560. So I put that in the quadratic formula, and we wound up with the square root of a negative. So there's no solution. This is the picture of what that looks like. Now you can, if you want to see this, you can put that on Desmos, like I showed y'all. Okay, so what if when you plug x into one equation, you get a y, but the other equation gives no solution? That means you got an extraneous solution. That's what that means. That means you just throw it out. You might remember we had a problem where we wound up taking the square root of -4, and with the other x, we took the square root of, I think it was 3 times 1 on the example. Yeah, that happens sometimes. So you just throw the other solution out. So if you get a solution for x, or you get 2 solutions for x, and you plug it in to get the y, and you wind up with the square root of a negative, that means that's not a valid solution. Okay. And I appreciate you guys asking. All right. So I know you guys want me to do 21, 25, and 7. Let's put a hold on that, okay? I will, at the very least, do what I'm doing right here. I'll do the problems and I'll share it with y'all. But if I have time at the end of today, I'll go back and do that. Is that all right? But I wrote it up here, so I will definitely do it for y'all. Yeah, exactly, Kenneth. Just, I'm not real big on rush in anything. Okay, so you can see what I did here, y'all. Let's see, let me get my brain straight. What did I want to do with y'all next? Okay, so I gotta grab this, put that there. And yeah, if I have time, I'll go ahead and do these problems at the end. So, okay. There's 2 kinds of interest. One kind of interest is usually when you go to a dealership and get a car. That's called simple interest. There's no exponents. And so the interest that you have to pay on the loan for a car, for instance, is based upon the principal, which would be the original amount, so the price of the car, times the percentage rate, which would be the decimal that you get when you divide the percent by 100, and then time. And this is usually in years. And I would venture to say always in years. Okay? So if we went to, say, the Honda dealership, like I did myself, I think 4 years ago, and I got a car, I think it was $21,000, but I paid like $6,000 down on it. So what's 21,000 minus 6,000? What's that? 15,000. So my principal was 15,000. And I think I got a percentage rate of like 0.7 something. Or no, sorry, 7%. So this would have been 0.707. And then I think I did it over 4, maybe 3 years. I probably did it over 3 years. So this would have been 3 times 0.07 times 15,000. And that would have been the interest. Okay, so let me show you all that math. I know that's probably easy, but I just feel like I should. So I got a car for 15,000. It was 21,000, but I paid down 6,000 on it. So I only had to get a loan for 15,000. Okay. And then I got a good interest rate, 7%. Honestly, I don't remember the interest rate, but let's keep this simple. And then I got the loan for 3 years. Okay, so now I'm going to quit sharing the screen and show you all this. So this is what that calculation would be, and that would be the interest. So the total I'm going to have to pay back would be the interest plus the 15,000. So this would be the total I'd have to pay back over 3 years. Okay, now we usually make payments per month. So if this is the total we have to pay back in 3 years, and you want to make a payment per month to pay it off in 3 years, then you would divide by 3 times 12 to get the payments per month. So this would have been my payment per month. Now there's also fees, so there would have been a little more than 15,000 because you got to pay the fees, and then you also got to pay the taxes. So I'm really oversimplifying this. There's also what do you call it? Warranty. So they'll warranty the car for any repairs for 3 years or maybe 5 years, but you got to pay an extra 2,000 usually. So there's other stuff, but I'm just keeping this simple. Okay, so this is called simple interest. Notice we're not using a growth factor. There's no exponents here. And so whatever the year is multiplied to the percentage of interest. The year is not the exponent. Okay. So simple interest, no exponent, you get the interest all at once, you add it to the original, and then you divide. If you want to find out your payment per time, you divide usually by the number of months. Okay, whereas compound interest is a little more involved. Compound interest is when you multiply a percent to the original and keep doing that. But the thing is, as you noticed when we were looking at this earlier, and we had the issues with the multiplying 0.01 over and over and over again, here, this is a lot easier to create a growth factor. And that's what this thing is on the left. 1 plus the percentage rate. The exponent is how many times you do that. So with the warm-up, the number 3 warm-up problem, this exponent was 3. This rate, the R, was 0.01, and the P, the principal, would have been the 5,000. And the amount we would have gotten over here would have been 5,151.505. So this would have been how that relates to the warm-up. Now this thing on the right is the same exact formula. It's just more specific to an application. Because sometimes we don't do things per month or per year. Sometimes there's every 3 months, which would be 4 times a year. That's called quarterly. Sometimes we do things every half a year. A lot of government operations will reconcile every half year. So they call it a fiscal year. Sometimes they'll do it every year. So the number of times per month, the number of times per year, the number of times per day, all of that is based upon a division. And so this N here is going to divide the percentage because you want to convert the percentage to be per a different time unit. Okay, so this I is usually used here, whereas over here we have the R. Over here we have the I. The I implies per year, whereas the R over here could be per anything. So if we want to be per month, we would divide the I, the per year, by 12, which would get us the rate per month. okay? And then here, the NT, that just means the number of times per year times the number of years, right? So if we did this in 3 years and we wanted this to be per month, this would be 3 times 12. And the interest rate per year would have divided by 12 because we want it per month. So this exponent has to be the same unit of time as what we're dividing the interest rate per year. Okay? Whereas over here, it just kind of simplifies that. This would be the rate per time. So whatever, if you want it per month, per half year, per quarter. And this would be the number of time units. So is that months? Is that days? Is that quarters? So these are really the same two formulas. Okay? And so I know you can read. I know you guys see this. And anybody ever used this stuff before, compound interest? Has anybody never seen this before? This is completely new to you? Okay, I'll just assume we're good. So we're going to finish up with this. Okay? Thanks, Briar. That's what I thought, but I wasn't sure. So this business is going to borrow $120,000 because they want to remodel the kitchen. The thing is, you know, this business might not have that much cash laying around, but they can make interest payments and pay it off in 5 years. And this is typical. Sometimes businesses, if they're small enough, can qualify for a small business loan to help with that, which is kind of going on right now with the stimulus package. So the Small Business Administration can get you really good percentages like this 6%. Whereas if you went to a bank, you might have to go to like 9%. So it helps small businesses manage their funds better and keeps them viable for a lot longer. So anyway, they're going to repay this loan in 5 years at simple interest. So this is what we just did. So we're going to take the 120,000, right? And we're going to multiply the 0.06, and then we're going to multiply 5, and then we're going to add back the 12,000 to see how much we're going to have to pay back. All right. We want to find out how much we have to pay back per month, though. So then we want to divide by the number of months in 5 years, which is 5 times 12. All right. So I'm going to show that to y'all. So this is what that would be. So you get your interest based upon simple interest. And then you would add it to the value of the loan. So this is the total you have to pay back. And then what are you going to have to pay back per month to finance this? 5 times 12. Now, sometimes businesses will pay off their debts in quarters. And this is true for very large businesses, not small businesses. So if you got like a McDonald's, for instance, or a Coca-Cola, they're going to pay off their loans so they might get a loan to build a new plant or buy some supplies so that they can make their product. So they might get a loan and pay it off per quarter. So if that was the case, then the number of quarters in 5 years would be 4 times 5. So this would be their quarterly payments. However, this is simple interest. Corporations and a lot of financial entities are based upon compound interest. Okay, and that's because they're actually bought and sold on the market. So a corporation will sell its loans to investors so they can raise the money cheaper, and then they'll pay a portion of that loan back to basically the investors get it. So they use compound interest. And when you're putting money into an investment that's growing, it's compound interest. So when we look at the last thing for today, let Let me see where that is. So this car dealer is offering these 3 arrangements. Okay, give me a second. Pierce just showed up. Okay, and so there's 3 arrangements here. So you can either get this $21,000 loan for 3 years with simple interest, or you can be 3 years with 8% compounded monthly. That means we're going to use the growth factor per month. Or you can get this loan for 4 years at a less percentage, 6.5%, but now compounded quarterly. Now, before we do the math, which one of these 3 do you think is going to be the cheapest? A, B, or C? Just think to yourself for a moment. If you had to just blindly pick one and you want to pay the least on this loan, just right now, what would you, as a human being who instinctively reacts to what they see without thinking, what would you do? What would you pick? Let y'all think about that for a couple seconds, and then we'll do the math. Okay, now keep in mind, a lot of people are preyed upon by their ignorance, all right? Just how it is. And sometimes a lot of financial terms are very arcane sounding and weird for that reason, because they kind of want to keep secret and prey upon other people's ignorance. So people looking at this might pick one of these. Since they don't know anything about mathematics, they might be vulnerable to paying more than they actually need to do if they were able to pick the best choice, right? Okay, so we got this simple interest problem first, and then we got the 2 compounded interest problems. Now, the only difference between the compounded interest problems, well, there's 3 differences. B and C, 1 more year. B and C, but less percent. And B and C compounded monthly, so 12 times per year as opposed to 4 times per year. So you'd only have to make 4 payments per year for C, and you'd have to make 12 payments per year for B. Okay, so now we'll go ahead and look at this. Everybody okay so far? Anybody want to say anything? Okay, so if we're going to do simple interest, then we're going to take the 21,000, we're going to multiply it to the 0.09, and since we're doing this over 3 years, we'll multiply this by 3. And then we'll add this to the 21,000. Now we're just going to look for the interest. So since this is the interest, that's all we got to worry about. Now, if we wanted to actually do the problem for real, you would divide that by 12 times 3. But we're just looking for the interest because that's what the problem is asking. Which one has more interest? Which is the better deal? Which has less interest? So that's that. So that's A. Okay, now B. Now B is compounded interest. Okay, so we got our 21,000, but now we're going to have to multiply a growth factor. So since it was 8%, 1.08, but this would have been per year. So we can't use plus 0.08. Since this was per month, we're going to have to add the interest per month. That's why we're dividing by 12. This is the rate of interest. The interest per year divided by 12. Because our compounding period is monthly. All right, that's the difference. If we knew what this percentage was per month, then we could multiply by 12 to get the percent per year. Here they gave us the percent per year, so we're dividing by 12 to get the percent per month. Okay? All right, now, this is per month, and it's over 3 years. So our exponent would be 3 times 12. Right, and that's what that NT was, right? T would be 3, N would be 12, because 12 times per year is monthly. Now this gives us the total value, but we want the interest, so then we subtract 21,000. And everything over the 21,000 would have been interest. All right, so again, we're doing this because we want to find the interest. If we just wanted the total amount, we would just use this first part. Okay, now part C. Now we're going to do the same thing. Since this is compounded, that means we're going to use a growth factor. So 1 plus 0.065. But this is not per year. We need to change this to be per quarter. So we can't use this per year percentage. So we need to change the per year percentage into per quarter. So we divide by 4. Okay, so now we got a growth factor based upon quarterly. So our compounding period is quarterly. Okay, so we're still doing this the same way, but we're using a different growth factor because we had a different percentage and we're dividing by 4 because it was quarterly instead of monthly. We also had one more year. So instead of 3 years, it's 4 years. All right, so we're going to have 4, but since we want to find this quarterly 4 times a year, there'd be 16 quarters in 4 years. Whereas up here, we were doing this monthly for 3 years, so there's 36 months in 3 years. Down here, we're doing this 4 times a year for 4 years, so there's 16 quarters. And again, since we're looking to find the interest, we would have done that. Okay, here would have been the values of the interest. This one was 5,670. This one was 5,674.97. So just a little bit more, right? Just a little, not much. I mean, you might not worry about the $5. I mean, it's just what, 3 years, $5. You probably lose $5, right? But C, now if you notice, with C, it was the one that had the smallest percentage, right? And it had the option of only paying 4 times a year instead of 12 times per year. So that might have been compelling. You might have gone, well, that's less percentage. I only got to pay this 4 times a year. I'm going to go ahead and pick C. Bada bing, bada boom. And so you would have picked C and you would have paid, what, $500, $600 more over. So these things can be deceptive, right? You can't always go by the numbers. So, and what do you think most people would have picked? People who are ignorant in math. What do you guys would have think most people would have picked? Right? Okay. You barely made it algebra 2. Okay. You struggled in course 3. You took statistics, right? So that's probably not really true because you guys are still smart, even if you struggle with course 3. But I imagine most people would have picked this because it's a less percentage. So this is why businesses do this, right? They know which one's cheaper, right? This is why we have consumer laws, because that's why. Can I go over the number you got in letter B? So the number, what particular, the growth factor? Is this one right here? Or the calculation? Oh, okay. So I did this 1 plus 0.0812, okay? And what I did is I calculated this to the 36th power, okay? I calculated that to the 36th power, and that was 1.27023. Okay, so then that would have become 21,000 times 1.27023, and then subtracted the 21,000. Yeah, you got to be careful with the calculator, and this could be me too. So I'll go ahead, I'll double check. Okay, all right, I'll just double check because you guys know sometimes I'm. So 0.08 divided by 12. Now I'd show this to you, but it's, it's right. I don't know if you guys can see that, right? Okay, then I'm going to add the 1. So plus 1, right? So that's our growth factor. And now I'm going to raise that to the 36th power. Okay, so the raise to the 36th power, you can see what we're getting, right? 1.27023. Okay, so now we're going to multiply that to 21,000 and then subtract 21,000. Okay, and so you can see that's what I did. Is that helpful? Cool. Does anybody need anything else? Okay, so I will do those odd problems, and I'll share that with y'all a little later. Okay, so 7, 21, 25. I'll be glad to do that, no problem. I sent y'all a missive, I think last night, maybe sometime. It's 3 pages of where we're at. Landon, let me get to you in a second. And there's a lot of uncertainty, honestly. The district's doing the best they can. I feel wonderful that I work with the people that I do because they've been straightforward, honest. They've been very helpful. They've even set up a phone line in case we get psychologically on edge, which is cool. But according to the state and the county health directors, there's not going to be any more school the rest of the year. I don't know if that's going to change because these things kind of go in flux, and the governor's been saying things lately, so I don't know. So I'm just going to work on the assumption that that's the case. Now, according to the district, we are not allowed to give F grades. So A, B, C pass. That's just how it is. So I don't think any of you guys would have a problem getting a C or better. And more than likely, you'll have the same grade you have now. Those of you who are on the cusp, might be a couple of you out there. So if that's you, it probably will matter a little more what we do from here on out through the semester. So how I average what we do here on out through the semester and what you had before, I'm still uncertain about that. I'm open for suggestions. I'm thinking 60-40, but it's the first time I've ever had to deal with this, so I'm just being quite honest. Let me answer a question. Connor, yes, email the warm-ups as well as the homework, okay? All right, does anybody else have any other issues? No, the do now is not important. That's not important. That's more of an example. So I'm only really worried about the warm-ups and the homework, okay? This weekend I'll work on a schedule. I had to see how this was rolling out. First time I've ever done something. So I have something to work with, but I didn't want to give it to y'all until I, felt comfortable, okay? Yeah, I would like y'all to do all the problems on the interest homework, okay? It's a lot of tapping on calculator. It's not like the homework from the nonlinear. Okay? Got plenty of time. You got the whole weekend, right? Okay, y'all, I'm gonna go ahead and check out. I'll leave it open for y'all in case y'all want to talk to anything, but shoot me an email if there's something you think of that you need. I'll work on the 7, 21, 25 a little later, and I'll share that with y'all, okay? All right, y'all take it easy.